So just to let all the Twitchers know, we're here and we're alive. So let's see. Just to make sure, when everyone installed Unity, there's a section where it gives you all these choose components kind of thing. Did all of you properly install the Android build or the iOS build, depending on which platform you're building for, just to make sure? All right, everybody, it looks like everything went fine there. Let's cancel that. Yes, I already have it installed, thank you. And let's get started. So hi, my name is Taro Mia. I'm the local Unity expert here at the Tech Valley Game Space. And I'll be talking about how to make VR applications with Unity. So without further ado, let's scroll all the way up on this. I think it's F11, isn't it? Okay, cool. And then, so the goal for this, this is a fairly long, I apologize that it's a fairly long lesson in regards to how to make VR applications. A huge part of it is actually due to the setup process of trying to get Unity working. So I'm just gonna go right out and say that our agenda for today is to basically get comfortable with the Unity game editor, which, as many of you may already know, is a well-known editor, well-respected game editor for VR applications. We'll be creating an interactive 3D environment with it and learning lots of 3D development terms that you may or may not have learned before. We're also going to get a very, very, very brief start on C# so that you can learn a little bit of programming. And I want to be clear that I'm going to do my best to kind of just gloss over the installation process, because honestly, this is a huge lesson, and I would like to cut as many. I'd like to make sure that we're getting through all these slides as quickly as we can. So with that, without further ado, let's get started. We start a new project by basically clicking on the new button at the upper right-hand corner right here. So let's just start that. And what you should get as a window is something that looks like this. So right now it's asking for a location and the project name. I'm gonna see if I can just put that on my desktop instead. I think that should be the right place. Yeah, it is. Okay. Nope, that is not the right place. I want you to go to my desktop. And we'll give the project name like the Super VR project. I can spell. One last thing. So there's a little 3D marker here and a 2D marker here. We're making a 3D application, so remember that you have 3D highlighted and an assets package. Let's see what my slides say. The assets package, we want to have these three boxes checked off. Hi, Brian. And prototyping. So click done. When you say done, there should be a number 3 over here. And you can just click on create project to get started. Just to note, by the way, that should you forget to do this by any accident, it is in fact possible to install them as necessary, but well, my Unity disappeared. That's great, awesome. So, without further ado, I guess we wait. There it is. We wait a really long time. Awesome. So what it's doing right now is it's actually trying to import those 3 packages that you've checked off. And you might be asking, where did those packages come from? Those are actually part of the installer. One of the checkboxes says something like standard asset package. What you're actually installing is the standard asset package stuff. And what I mean by importing is that it's actually creating a new folder project with the assets and the project settings folder. And it's dropping pretty much everything. It's dropping all of its imported packages inside the assets folder, which we'll go over in more detail as to what that is about. Guys, it's taking a really long time. I completely forgot how long this process actually takes. Let's see if I can kind of jump around a little bit. Okay, so excuse me as I check to make sure one thing. All right, looks like it's working. So I'm just going to skip over for a little bit and talk a little bit about Unity. Unity, as you know, is a what you see is a what you get 3D and 2D game engine. It is primarily 3D. It's easy to emulate 2D with 3D anyway, so it's primarily a 3D application. And it has many built-in features, including physics, sound, scripting, gamepad support, plugins, and more. Yeah, more. The main reason, the main popularity about Unity is that using exactly the same code, well, almost exactly the same code that is, you can build to many platforms by using this game engine. You can build it to PC, Mac, Linux, WebGL, iOS, Android, Windows 10, Windows 8, Kindle Fire, PS4, PS3, PS Vita, Xbox One, Xbox 360, Wii U, the new 3DS, that underline is there for a good reason, Ouya, Samsung TV, Zen, and more. What we're using is the personal license, which is a free license right up at the top there. It says this, will build to the platforms that are listed under the installer, including Windows, Mac, Linux, WebGL. You can ignore Web Player, that's deprecated. iOS, Android, and Windows 10. It uses C# and JavaScript support. We're going to be using C# in this case. That seems to be the more popular choice. But just to let anyone know, there is JavaScript support as well, if that happens to be your cup of tea. And it's totally okay to sell your game. There's no royalty fees. The exception is that you have to be making less than $100,000 per year. The Pro license, this is actually outdated. I'm going to skip this. And let's see how much progress. Oh, yay, Unity opened up. So this is not what your Unity looks like. This is what your Unity looks like. Excuse my customization there. If you're curious what I did, you can actually drag these panels anywhere you want to, but I'm going to switch that back to what it used to look like. So, without further ado, with VR setup, there is actually a lot of setup process to make Google Cardboard VR work. So we're going to go through this one step at a time. When you start off with Unity, okay, that turned out to be a lot larger than I expected. When you start off Unity, make sure that you click on the Edit, and there will be a preference entry. This will bring up a dialog here. File, Edit. Preferences, module. Oh, if you're using a Mac, it's the Unity menu. Excuse me. Yep, so that should open that. And then when you go to external tools, what you'll need to do is you'll need to fill in the SDK. Oh, whoops. What? No. Oh, that's so weird. Why'd it do that? Alright, give me a minute. Apparently I messed up my own computer. That's fun. Alright, but yeah, I'm already demonstrating it here, which is that you click on, if you haven't set the SDK already, make sure you click on Browse and look for where your Android SDK folder is. The Android SDK folder is what basically contains the content that you're seeing here, including add-ons, build tools, extras, NDK bundles, platform tools, and so forth. If you do not have this installed, that means you don't have Android Studio installed yet. So if you don't have it installed yet, don't fret. I guess we'll go over this at the end of the conversation.
What should I say for iOS?
For iOS, you don't have to do anything. But you do have to have Xcode installed. Okay, cool. JDK, again, if you're using Android, you also need to fill in the JDK field. If you're installing the Android Studio, it will actually prompt you to install JDK as well. And again, the process is very similar. You browse for it, you look for the Java folder, and then you choose Actually, I chose JDK 1.7 is the one that's recommended. JDK 1.8 works as well. So one of those two. And then it says NDK here, you don't need to worry about it. The warning here lets you know that you don't need to worry about it. So I'm going to completely ignore that. And let's close that. And that's it for that. For the VR setup, what we need to do is we need to open up the build settings. And can I safely assume here that everyone's going to be building for Google Cardboard?
Yeah, Samsung VR, but they can use Cardboard.
Samsung VR. I'll go over that real quick. And then there's an iOS here. Okay. So in this case, once you bring up the build settings, there's a couple of buttons that you're going to be most interested in. There's the iOS and the Android. Make sure you select the proper tool for your platform. If you're going for iOS, just click on iOS. If you're going for Android, click on Android, and hit the switch platform button at the bottom left-hand corner. This will cause this to appear, and it will actually re-import all the standard assets. Wonderful. So that's going to take a really long time. Fun. What you're actually doing is that it's actually re-importing all the assets that you're importing at the beginning, specific for that platform, which means that it's recompressing all the images, for example, so that you can actually load it on that platform. So that's what's going on.
That's only for Android.
Huh?
That's only for Android.
It should also, the same thing should happen for iOS as well. I assume that you selected the iOS and hit the switch platform.
Okay.
So this is unfortunately a long and tired process, but I'm going to give you a quick preview. The next thing we're supposed to do is we're supposed to hit the player settings button and then close the build settings. And we'll actually talk a little bit about what's going to happen next. Earlier, somebody mentioned the Samsung Gear. There's a little checkbox here under other settings called a virtual reality support. If you're using a Samsung, if you're trying to export to Samsung Gear, that checkbox needs to be checked. If you're using Google Cardboard, please leave that unchecked. That also applies for iOS, which doesn't have this checkbox anyway, so you can't do it. Far more important is to make sure that if you're an Android user, make sure that your minimum API level is the SDK version you have installed. Ideally 5.1, which is from what I understand, when Google Cardboard was first. That's like the OS that was recommended the most. Or your device's API level if lower. When you're actually installing, Android Studio, I believe because 6 or 7, one of those two, are the latest, it's going to be installing that. So by default. And you want to make sure that the SDK manager in fact contains the SDK that is at least the same version, if not a couple of versions lower than your actual device itself. Let's see if Unity, is it still progressing? Yeah, it's taking a sweet time. I'm a little afraid to go beyond this. Couple of other things. Yeah, I'm a little afraid to go beyond this, so I'm going to actually wait until Unity is done loading here. I completely forgot how long this took. Okay, we'll worry about that later. Also worth noting, since we're waiting for that anyways, make sure that when you installed that, or when you downloaded that zip file, make sure that you have all of it unarchived at a folder. It contains a couple of assets, including these wonderful stuff. But the most important one is this Cardboard SDK for Unity. We're going to need that very soon. If you're building for Samsung VR, by the way, you don't need to go through this process of importing this package because Unity already has built-in support for Samsung Gear. It is only Google Cardboard that does it currently does not have built-in support for it. I am told that they will. I'm told that their next release is this month, which
Is that
there's
just
not.
because there's like lots of different hardware associated with that versus the Samsung is just a few components or?
I have no idea. I would like to know why too myself. I think it's done. It looks like it's done. All right, so player settings. Here we go. Now we're cooking. So I just click on the player settings button. If you can do the same thing on your build settings dialog. And what should change is the inspector pane on the right hand side. I'm going to close the build settings because we don't need it anymore. Remember again, if you're using if you're going for Samsung VR or you're using Oculus, then to make sure that you have this checkbox checked. If you don't, for example, if you're using iOS, there's not even a checkbox there because apparently they thought, who cares about iOS? But again, if you're also going for Google Cardboard, leave this unchecked. Make sure that if you're using Android, that the minimum API level is set properly. Apparently 6 is the latest that it has. But in your case, whatever is your version of Android, whatever SDK you happen to have installed is the one that you want. For me, I just happen to have Gingerbread 2.3.3, so I'm going to be using that. Actually, I don't think my computer builds Android applications for whatever reason, so ignore that. Ignore whatever problems I encounter. One last thing, make sure that your orientation is set to landscape left, I believe. Landscape left, yes. The reason why we're switching it to landscape left, by the way, is to make sure that it doesn't auto-rotate on you. And that should be it. Forward. Make sure that this.
Landscape
Oh, yes, the landscape app. If you go to the resolutions and presentations, if you click on that, you'll get an option. You get these couple of options. The first one is the landscape left. Default rotation. Huh?
Was that supported? Is that just mean it's because the built-in Samsung here?
I'm sorry, what?
It's grayed out for me entirely, so I assume that's because they're using Samsung here.
Let me check that. Yes, the setting is overridden by virtual reality support. So the answer is yes. Awesome. So, with that then done and said, let's get started on, oh, I also forgot about this. So one last thing, we need to also import the package that I just talked about earlier. The way to do that is to go to Assets, Import Package. Again, this is for the people who are building for Google Cardboard, regardless of whether you're using iOS or not. Click on Custom Package. We're going to look for that VR with Unity 5 assets zip content. Click on the Cardboard SDK for Unity, open. It'll decompress a bunch of things. Still decompressing.
Is there a way to check if you already have it installed? Because I think I might have installed this yesterday. I might have installed this yesterday. Is there a way to check?
I don't think you have it installed at all because these are actually new assets that we haven't actually imported. And then you'll see a bunch of checkboxes. I don't care, import it all. As mentioned earlier, you don't actually install that package. What you import is content in your project. So let that sit there for a while. Obviously, we've already went through this where you have a bunch of things unzipped. make sure that you have the level.fbx, the grasp.png, rock JPEG, hit wave, and the drag rigid body CS in that folder. As you can see, drag rigid body, grasp, hit wave, level FBX, and rock JPEG. I also didn't go over what that instruction actually says, but I'll worry about that later. Going through a bunch of things. So, how is everybody doing today? Yeah, what's up? By the way, feel free to interrupt me with questions that would we still don't have All right, is everyone, with a plausible exception of Robert, sorry to single you out there, done with that? Okay, so I'm just gonna resize everything real quick so that I have some screen estate to work with. All right, so fun stuff. All right, it says here, open in your favorite file browser. From there, with the unzipped files, move all these files into the project assets folder. So I dropped everything here on the desktop. According to my desktop, this is the Super VR project is where my project is, and there's an assets folder in here. So make sure you open that, and then pretty much move these, cut and paste all these here into your project's assets folder, and then return to Unity. And then you're going to see a progress bar again. I swear this is the last progress bar you're going to see, with an exception of, oh, that's right. I need to open Visual Studio at some point. So cool. I assume everyone got all the way up to there. Just real quick, because these assets were in fact under the Creative Commons license, and I want to give proper credit to them. The Level FBX is a modified version of the MP full blend from CTDA BOM, released under the CC by Creative Commons license. It's supposed to be the Machu Picchu, as you can see the link up there. The link is from Sam Uncle, and the rock JPEG is from Marianne Gagnon, and the Creative Commons license is all the way down here. So we've already went through this. That's outdated. Let's start making a game. Earlier I mentioned that please drag and drop all your content inside the assets folder. You might be asking why the heck we did that. Assets is pretty much everything that we use inside the Unity itself. At the very bottom here, we have the project pane. And then, as you can see, this actually shows all the content that we've just dragged and dropped into the assets folder, along with all these couple of other folders that we imported from either from the standard assets or from the Unity package that we just imported earlier. The cardboard, for example, is from the Unity package, while the editors and the plugins and the standard, the plugins is actually from the cardboard. The standard assets and materials and the editor are all from the standard asset stuff that we try to import when creating the new project. So this is going to be our go-to for finding any sort of file necessary for our project. Just to let you know, this little bar right here is the search bar, which I think we're going to use very extensively. It's been a while since I went through this project, but no matter. Okay, so let's add a model to the scene. The best way to do this is drag and drop level the FBX from the project pane into the scene pane. That's literally just it. So drag this into here, and you can see it work because you see the thing there. I'm just going to let go, and you can see the whole thing like a true majesty. So yep, that's there. That's awesome. And then make sure that you save your scene. When you save your scene, you can do that either by file and save, or Control S shortcut that tells you right off the bat. It's pretty much standard. And we need to give this scene a name. I believe I'll just call it level. VR level. And then that'll create a VR level inside the assets folder, because that's where you told it to be created in. Excuse me. Let's go through some quick vocabulary here. Assets is the industry-wide term for any sort of files used in the game. In this case, for Unity, that's basically anything inside the assets folder. No wonder it's called that name. Models. Models is an industry-wide term for 3D sculpture files. I'm sure many of you know this, but in case you don't, whenever I talk about models, this is exactly what I'm talking about. I'm talking about these files that contains the 3D information in sculpture. They can often contain animations. FBX in particular is known for this. Usually they're made in specialized programs such as Maya, Blender, etc. I want to be clarified that Unity is not a 3D modeling application. You do not make 3D models inside Unity itself. Granted, there are plugins to do that, but it's not considered the best solution to do that. You want to make sure that you do that inside other applications instead, as the aforementioned Maya and Blender being the most popular options here. The scene pane is the pane where we show basically what the scenery looks like. Earlier, we created a scene file called VR level. So in other words, a scene pane, in a way, kind of provides a visual graphic of what the content of this file actually contains. It's also a place where you can kind of position, move around, transform your model, which is really useful. I should also mention that the kind of 3D models that Unity can import are FBX files, Collada files, 3D Studio files, wavefront files, and draw interchange files. Most of the time, the most recommended one is FBX. I believe Collada is pretty good as well, being that that's a text format. OBJs does not support animation, so that's a little weird and tough to work with. I believe 3ds Studio does not support animations either, but both Collada and FBX does, so that's why it's generally recommended that you try to use those. Importing 3D models. If you happen to have any of these applications installed, you can also import these models as well. Blender, which is really wonderful because in Blender's case, it's free, so there's no reason not to have it installed, really. Maya, if you do happen to have the money or the license to install Maya on your computer, yes, you can import Maya files natively. 3ds Studio Max, same thing. Modo, Cinema 4D, Cheetah 3D, Lightwave, so on and so forth. Navigating the scene pane. Generally speaking, it is recommended that you try to use a 3-button mouse. I know a lot of you are using touchpad. God bless you, but it is not the best way to control what's going on inside the scene pane. So see what you can do to deal with these problems. But for what I was able to research on, the 2-button mouse controls are left click to select an object. This is an object unselected. This is an object selected. You can tell because it's all blue and glowy and there's a little word control that shows up. Hold out and the left mouse button to rotate the camera around the scene origin. Out and left mouse button. Oh, like this. I didn't know you can do that. Huh. Hold control out and left mouse button to pan, like so. Hold control out and right mouse button to zoom, where you can move up and down to zoom in and out. Same thing can be done with 3-button mouse. It's honestly a lot easier. Left click. Hold the right mouse button to rotate the camera around the camera position. So this is what the right mouse button functionality looks like. The scroll wheel to zoom in and out. Whee! And then finally, click and hold the scroll wheel to pan. So I'm clicking down on the scroll wheel and I am panning like no tomorrow. Also remember that holding shift allows you to pan and rotate a little faster. So this is the normal zoom in speed. This is it with shift, which apparently nothing changed. This is the normal panning speed. This is it with shift. Wonderful. Manipulating objects. This is actually fairly simple. You see these little controls up here on the upper left-hand corner? These are your ways of manipulating your objects. This first one is the transform tool. The transform tool is pretty simple. If you click on the red arrow, you can move it on the x-axis. If you click on the green arrow, you can move it on the apparently z-axis. And this one on the y-axis, and the blue, the y-axis. And that is how you move your things. You can also click on these little squares and it'll keep it within a certain plane of that. So that's what those squares stand for. Yoink, yoink. There's also the rotate control, which is this one right here in the middle. The rotate control, you just have to click on these little green, blue, or red axis, and then you move it up and down, and you can rotate your level like no tomorrow, like there's an earthquake. I was going to make a really offensive joke, but then I forgot the country, so I'm happy I didn't do that. Scale is fairly simple. You click on that, and you have these little buttons. to allow you to scale, widen, or shrink your object as necessary. There is also, more importantly, this square, which allows you to do a uniform scale. I'm just going to set that back to where it originally was at. And the 2D sprite tool. We're going to completely ignore the 2D sprite tool because we're not working in 2D space. We're working in 3D, and 3D it shall remain. Pan tool is the obvious one, the last one that I haven't mentioned. It's the little hand here. It just turns your hand into a normal pan tool when you left click versus the regular time when you click on something, you can't actually do anything but still make a box selection. You can toggle the object's reference points by clicking on these buttons. These are actually toggle buttons, which is really weird. I'm going to stick with the default settings here, which apparently when I started was center and local. But you can play around with those and see what you think fits for your situation. And finally, the play game controls from left to right. This is the play button, this is the pause button, and this is the move over one frame button. It's pretty simple. The hierarchy pane. The hierarchy pane appears on the left side of the screen, and they tell you what the content of the scene is. So in case you haven't kept record, the scene pane here shows you graphically what the content of the VR level looks like. But it is in fact possible to create invisible objects inside your scene. So that's where the hierarchy pane comes in play. The hierarchy pane pretty much shows you all the things inside the level, even the stuff that are invisible, such as, for example, this directional light, the directional light being the light source of our scene. We'll also go, this is actually a tree graphic, by the way, and we'll go over what I mean by that. You can drag objects into another and turn it into a child of another object. So if somebody here knows what the term for kinematic stands for, you're already ahead of the game, but basically that's your way of creating a forward kinematic animation. Some lexicon review, game object. Game object is actually a Unity term. It is not an industry term whatsoever. Game object is Unity's term for any individual object. Anything that is listed here in the hierarchy are game objects, flat out. They can be inactive or deactivated. You can do that by clicking this, and you can see that it's deactivated. You can click it back again to activate it. For the most part, we're actually not going to be touching that at all, so don't worry about it. So yeah, that's that, and then they show up in the hierarchy pane. For the scene, Unity's term for files storing a collection of game objects. So basically, what is stored inside this VR level is this whole content right here that you're seeing under the hierarchy pane. So that's how the scene files work in Unity. It's just containing those stuff. Generally speaking, it's a good idea to put them under the assets folder, because let's say you're switching between different scenes, then you can just double click that scene. Yes, actually save. Don't double click on the scene, by the way. Don't double click on the scene, by the way, sorry about that. But I did it for the purpose of demonstration. Notice that it prompted me to save. That's because it's going to close the scene and try to reopen it again. But generally speaking, double clicking on scenes allows you to open that automatically from the assets folder, which makes it incredibly convenient and easy to switch between scenes. So, adding textures to this model. So what I mean by this is that this model looks very, 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 very flat. And what we need to do is, or what we want to do is we want to add a little more detail to it, a little more spunk, some taste, right? So the best way to do this is to click on the level itself. You can do that on the scene itself or on the level here on the hierarchy. Both of them are effectively going to do the same thing. If you actually look very carefully, when I click on this level right here, it already highlights on the left side of the screen right here in the hierarchy. It highlights it there. If I were to do it the opposite thing, where if I click on the level, it also highlights on the scene pane. So so the hierarchy and the scene basically are like two interchangeable things. If you make a selection on one of them, you'll also make a selection on the other as well. Anyways, what's important here are the materials that are at the bottom of the inspector pane here. In this case, we have the grass dart and the Horton rock wall, and looks like they're expecting some sort of texture on them. So for our grass dart case, we already have this grass texture in there. So we just need to drag and drop this grass under the albedo square once you expand the grass dark. And already, we got grass! Exclamation point, 1 exclamation point. And likewise for the Horton rock wall, to fix this little gray wall right here, we just have to drag and drop this rock and drop it onto the albedo. And look at that. Look at that majesty. It's a lot less flat now, which is what matters. We'll click on the level. Expand the grass. You want to drag and drop the grass texture. No, it is supposed to be color. Wait, let's get that. You know, I never actually questioned what albedo stands for. All right. So we got that, and it looks beautiful. The inspector pane. So let's actually talk about this inspector pane here. The inspector pane, so each game object actually has more information on them. And the inspector pane sort of acts like a properties dialog, if you recognize that from Windows or from Mac. Or like the get info on the Mac. A properties dialog that gives you more information about what the content of that game object is. These are each, by the way, are called components. I think I go through the lexicon on that, so I won't go any further on it. In this case, we have 3 different components: the transform, the mesh filter, and the mesh renderer. But yeah, it displays all the property details on the selected game object. One can edit the properties here. In regards to images, Unity can actually natively import PSD files. So if you're using Photoshop and don't care to export it to PNGs, Photoshop, totally the way to go. So yeah, go for it. It also obviously imports PNG files, JPEG files, unanimated GIFs. I'm sorry, it does not import animated GIFs. I have not seen a way to actually do that, so sad days for me. Paint, it can import BMP files, TGA files, and a lot more. I will check the Unity's website to see what the documentation says, but obviously, you know, PNG, JPEG, and GIFs, and PSDs are the grand majority of the image files that you'll be receiving or using anyways. I also want to talk about textures. So I use the term texture. Texture is basically an image that represents how a model is supposed to be painted, right? It is an industry-wide term. If you work for animations, game development, or any sort of 3D related stuff, everyone uses the term textures. Models usually contains coordinates of how these textures are mapped onto the model, which is why when you drop that texture onto the Machu Picchu model, it was able to figure out where to basically repeat that texture pattern. It just knew how to do that because the model itself had that data in it, the FBX file. The coordinates themselves are called UV coordinates. Fun fact, UV is called UV because they ran out of letters. They said, okay, X, Y, Z for, you know, normal global coordinates. And then you're like, all right, so we need to add the next set of coordinates, which is UVW. They forgot the W, and now you're left with only UV. So that's the joke that's the origins I've heard of that story. Someone helped me debunk that story, but I think it's the greatest story of all time. Anyways, components. As mentioned earlier, the inspector pane pretty much shows what the components are. Components are Unity's term for containers with specialized information. They're the ones that are actually showing the graphics. Game objects themselves do not actually have any graphical information to them. The mesh filter does. The mesh render component on top of that contains information such as what materials should be attached to that. Game object retains a list of components. These can be enabled or disabled. You can easily prove this by checking or unchecking the mesh renderer, where if you uncheck the mesh renderer, the whole thing entirely disappears. And then just to let you know, every entry in the inspector pane is a component. You can tell that these components are separated, but because anything that you can collapse are a single component. So this is a single component, this is a single component. These are actually not components. These are materials held inside the mesh renderer itself. So those are the only exceptions to that rule. So at this point, like if you were to play the game, nothing's gonna happen. Heck, I might as well demonstrate nothing happening. There it is. Nothing's happening. I even placed a camera at the wrong place, darn it, so that's my fault. I shot myself in the foot there. Anyways, so what we need to do is we need to add this camera that actually moves, right? We're going to make it so that you are experiencing the VR in the most pure raw form on the PC, unfortunately, but we want to make that happen. So in this case, the best way to do that is that Unity already made a script that allows you to create a camera that moves like any other first-person shooter game. So the best way to do that is to search for, under this little search bar here, the FPS controller. And I'm going to choose this first one because this has better aerial control, and just drag and drop it into the scene. And you'll notice that it will create a little capsule thingy over here. Okay, I lost you. By the way, in the case like, I'm going to demonstrate this. In the case of when you completely lose sight of where you're at, there's a keyboard shortcut for this. So long as your mouse is on top of the scene and you have selected the one thing that you want to focus on, you can click on F to refocus on that object. But I'm going to try to get this capsule to be as close to the ground as possible. I'm going to try to see if I can place it in the right place, the one single location that must be placed. Feel free to have a little bit of fun with this. Let's place it right around here. Yeah, that looks good.
How are you moving camera?
I'm holding the right mouse button. I know you're using a touchpad, so you know what? Unity, one mouse button, rotate camera.
It's hold option.
Oh, okay. So here's our wonderful capsule lying down here. And we're also going to get rid of this main camera inside the scene. So you notice that there's a main camera in there that was already there since we first created this, or when we first opened this application. We're going to delete that. For Windows, it's just delete. For Mac, it's Command backspace, just like deleting a regular file, and you'll easily get rid of that. And I'll save the scene. Oh, there. FPS controller, drag and drop FPS controller. Position the FPS controller right above the ground. So, yes, we got that done and working. Google Cardboard people. So basically, everyone in here that is not using Samsung VR, you'll actually have another step to do. Google Cardboard requires a script to be placed on what is going to be the camera itself. So here you need to expand the FPS controller, and already actually we're having a demonstration of the child and parent relationship. Click on the FPS controller right here, and there is an add component button at the very bottom. What we're going to be looking for is, I believe under cardboard, oh, I just searched for it, never mind. Add component, we're just going to search for it. The thing we're searching for is stereo controller. And it's this first entry in here that I tried searching for, and that's it. Yay, stereo controller, we did it. Stereo controller. Everyone so far up ahead with that?
Yeah, it's still your VR element zone, or?
Yeah, we're talking about Google Cardboard stuff right now. And that should make the stereo controller appear here. And let's play the game! Now, I saw that, yes, somebody has already gotten a head start on actually playing the game and realized that what happens is you fall through the universe. Yeah, and you experienced existential dread of what it really means to be alone forever with no one to help you. But we're going to fix that! Just want to make sure that everyone got to a point where you can actually play the game. Robert, did you fall through the ground?
No, I think froze up. You got that since you restarted.
You guys are supposed to fall to the ground, right?
Huh?
You're supposed to fall to the ground.
Yes. Especially for you, Patrick, if you already went through the 2D tutorial, right?
Yes.
Yes.
I mean, I know how to probably fix it, but it's fine.
No. The reason why I say that is because I'm like, you probably are experiencing a big, huge deja vu because this is my way of doing things. Anyways, so the reason why we fell through the floor was because while our wonderful capsule here, our FPS controller, has what's called a character controller, which in and of itself acts like a collider, our level does not have any collider whatsoever. It's just all graphics and for show, which is great and all, but that also means you fall through the ground. So the best way to fix this is that we need to add a collider. A collider basically makes something feel solid. So in this case, with our level, all we need to do is we need to go to Add Component, search for Mesh Collider, and add that in. So I'm going to compress those. But click on Add Component, and we're looking for Mesh Collider. Alternatively, instead of searching it, you can go through the physics, and it'll be listed as one of the colliders. So you just drop that in, and now you have a new Mesh Collider that automatically sets everything up. You should be able to just play the game after this. And then in doing so, I can't move around weird. Oh, you know why? Alright, so if you're like me and you find yourself unable to move around at all, I believe that is because, yep, here it is. Ah, darn it. No, come back. I have a call. All right. I think if you take out mobile input from your scripting defined symbols, which by the way is under other settings. So you need to click on other settings first. Go through the scripting platform defines, and then take out semicolon mobile input. Oh, give me a minute. Sorry, I have to take this call. apologies. That was my parents delivering some bad news. But I'm all right.
Question.
Yes.
How do we get to say the name of our right here? It's like none.
I'm sorry, what?
I played it and I fell through. Was that no? It should not be. Search for that.
You know what? I think it was placed that on the wrong place. Yeah. Close that for a minute.
I just got one.
Then. Move that.
Okay, so,
Do I need to add the FPS controller again? Huh? Do I need to add the FPS?
Yeah. Anything that happens in play mode literally disappears.
it's like Vegas. What happens here? I still can't move.
Give me a minute. I'm trying to debug that right now. All right, I can move. Got it. So Patrick, once again, when you go through, open up build settings. Make sure your platform is selected and click on player settings. On the right-hand side under the inspector, make sure that other settings group is expanded.
Okay.
And it should say scripting defined symbols. One of them is cross_platform_input. The other one is mobile input. Make sure you delete mobile input. Huh? And then if you did that, press tab or enter. And now close build settings. It'll actually think a little bit. You can tell because of the bottom right hand corner there's a little cursor that appears. And you should be able to play the game again.
What are we clicking on other settings?
Huh?
What are we,
Oh no, you don't need to worry about that for
just we can't move there.
oh, okay, yeah. Go to under other settings, where it says cross-platform input. It'll say semicolon mobile input. Take that out and press enter or tab to commit those changes.
Is that like for controller or something?
Huh?
Is the mobile input like for controller?
Yeah, exactly. It's expecting that controller. But so you should be able to move now for Android people. And the way to do that is just move the mouse around to look around. Space is to jump. And WAS, WASD, or arrow keys to move around.
Do you have the two view
Because it's Google Cardboard. Samsung VR is not going to look like that. There are also a couple of controls listed in the Google VR SDK here. In play mode, if you press Alt and move the mouse around, you can pan horizontally and tilt vertically around the scene as if your head is moving in the VR thing. So I'm going to hold it Alt, and it'll let you finally look up and down. Yeah. Awesome. You can also use the control with the mouse to simulate tilting your head side by side. Woo, Dutch angle. Yeah. So that's how you play our game. And then if you want your mouse back, you just hit escape, ESC, and your mouse will be back here, and you can click on the
Arrow
play button.
keys move you around.
Yes. If it does not work, that means that you need to remove the mobile input from the build settings. I mean, is the arrow keys working right now? Yeah, that's right. Okay, so you need to go to edit, go to project settings, go to player. Stuff, other settings, scroll down. There it says mobile input. You need to remove mobile input on the scripting files. Yeah. And you need to commit that, so press enter or tab. Cool. And you can see that Unity is thinking, so it's going to take a little bit, and then we're not stop thinking. We should try to play the game. Yep, and then you can press space to jump over. Yeah. Anyone else having the problems? No? So the mobile input strikes again, but we have successfully conquered. All right, cool.
So is there any way to like preview the like 3D dual screen thing with the Samsung?
I think the way it's supposed to be is that you connect your device, like for Oculus at the very least, you can actually have a real-time preview. When you have the Oculus connected to Unity, it will automatically show the same thing. The Oculus will show exactly the same thing that's going on with Unity as well. So I'm assuming the Samsung Gear is supposed to do exactly the same.
So you just like link your phone and computer and be there.
Right. That is supposed. I'm assuming that's what happens. That's something that unfortunately I did not go through thorough research on. What I did thorough research on was Google Cardboard. So at least my research was where it counted for most of the people here in attendance. But unfortunately, I'm not nearly as knowledgeable about Samsung VR. We've already went through this. Fun. Marvel at your own work. All right, so some lexicon review. Earlier, what we dropped in was something called a prefab. So you see this FPS controller here. This specific icon means that it's a prefab. And a prefab is basically Unity's term for, in short, a prefabricated object. These files usually have a prefab file extension to them, and they allow copying a group of game objects from one scene to another. They're actually more complex than that. They have a lot more extra functionalities added to them. But for now, you can assume that basically prefabs allow you to copy and paste a group of game objects from one scene to another. Colliders. Collider is a fairly common term that the industry uses that describes the shape and the boundaries of a certain object. They're usually used by the physics engine to determine where the objects would collide and how to act from them. There are different kinds of colliders, including the mesh colliders, the box colliders, the sphere colliders, and the capsule colliders. All of these are named almost exactly the way you would expect them to. Mesh colliders shapes itself based off of the model itself, which is the Machu Picchu. That's why when we dropped a mesh collider onto the Machu Picchu level, it automatically calculated and figured out where its boundaries are. Mesh colliders are expensive. Generally speaking, you want to make sure that they are used on stuff that remains still and uninteractive. Box colliders are very, very efficient. They are a shape of a box. Simple. They can be of any rectangular size, so they can be of any dimension and of any rotation value. And we'll be using one as an example very soon. Sphere colliders are also incredibly efficient. They are spherical shaped colliders, and they do not support ovals, unfortunately. Capsule colliders is the best alternative to getting an oval-like shape. They are shaped like colliders, and they're typically used for character collision marks, such as marking off the limbs or the torso, that kind of stuff. They support height, but again, there's no real oval support. So in our standard script, if you moved around, you might notice that your head bobs. And general VR practice says that is a bad idea. So we're going to remove the head bobbing for right now. The best way to do this is simply going to the FPS controller, and you might notice that there's a lot of parameters here. One of them called use head bob. Uncheck that and try playing the game again. You should instantly notice that the view is a lot more stable when you move around. And that should be infinitely less nauseating than if you left the head bob in there. So, I'll let you guys have your fun time with that, and then let's get into the next slide. Okay, the interactive stuff. This is where things get fun, yay! Adding interactive objects is really cool. All you have to do is to create a cube pretty easily. You can do that by, I believe, right-clicking, I guess not. You can do that pretty easily by going to Game Object. Then there's a couple of objects that you can create here. In our case, what we want is a 3D object. We're just going to drop the cube, and there it is. Here's the cube. It looks fine and dandy. If you try to play the game as it is, where the cube is, you might notice that the cube it just hangs there in the midair. Yeah! And we can jump on the cube, but that's all you can do. So, I mean, that's cool and all. Let's see. Let's check to make sure that that's actually within view. That cube could move a little more directly in front of the player. All right. So, I mean, that's cool and all, but what we want to do is we want to be able to move the cube, right? The best way to do that is go to Add Component. By the way, you might already notice that the cube itself already has a mesh renderer, and far more importantly, the box collider that we were talking about earlier. So it itself already has collision. That's why you can actually jump on top of it. Add Collider. We're going to go to Physics here. We're going to add the component rigid body. And now you can play the game. Yeah. And, oh, you can actually move a cube. Neat. So, you can push the cube around. Play your own sad version of soccer.
Is there a way to change the size of it?
Huh?
Is there a way to change the size of the cube when I draw it in? It's like really small.
Yes. There's a scale thing right here.
Oh, okay, cool. Thanks.
Yeah. All right. I'm having way too much fun with this. Sorry about that. So that's how you get the cube to actually be an interactable thing, by simply adding a rigid body to it. It's pretty simple. So let's add a little more to this. Let's add like a gravity gun from Half-Life 2, I guess. In the project pane, we can drop in the drag rigid body script into the FPS controller into the hierarchy pane. So the way we do that, I'm gonna X out our search. Here's our drag rigid body. We're gonna drag this into here, the FPS controller. When you do that and you select the FPS controller, you'll notice that now at the very bottom, we now have a drag rigid body script attached to it. I hope I put that in the right place. Yeah, cool. So now all you have to do is just look at that cube, stare at it intently, and then hold your mouse button down, and now you grab the cube. And in this way, you can express your hatred of the cube. You can also grab the cube from any distance. So yeah. And that is how you grab a cube, how you make, or that's how you import or attach scripts onto a game object, which is literally just dropping it into any of these hierarchies. You can also drop it inside the inspector itself. It's all drag and drop. Fun. I actually wrote this drag and rigid body script from scratch. Feel free to copy it. I don't care. Consider it public domain. I'm sorry, what? Yeah. There's a couple of open source stuff that allows you to do a lot of handy things. So let's talk about weird shapes. Rigid body is kind of funky and interesting in that you can actually create composite shapes with it. To demonstrate that, let's drop a sphere onto the cube. The best way to do this is to actually create a game object again. And then let's select a sphere this time. Okay, I'm going to switch to the transform tool because I want to actually see the sphere. And here it is, sphere. I also completely forgot to, I made it different size, so I guess I'm going to match that size. And I'm just going to place a sphere like right around here. Feel free to customize that as necessary. I'm just placing it here for no real good reason. I just feel like that's a good place to put it. And earlier I mentioned that you can drag and drop. The hierarchy is actually a tree view, and we already see this in the FPS controller here. But we can actually do the same thing for the cube itself as well. Right now the cube has a rigid body on it, so we want to make sure that that's the parent. To child the sphere onto the cube, you drag the sphere into the cube object itself. The cube, make sure it's highlighted to look like this. When you do that, you'll notice that now you can expand and contract the cube to make the sphere reveal itself. This is something called forward kinematics. It's a pretty neat thing. When you do that, you can now move the cube around and it'll move the sphere with it. While if you move the sphere, it won't affect the cube whatsoever. But if you move the cube, you can move the cube and the sphere at the same time. This also works in-game as well. When you play the game, let's grab this composite object of ours, and you can kind of throw it around, and it'll interact quite realistically, as if, you know, it's all just one Katamari object. If you also make the cube large enough, you can jump off of it infinitely, but I'm not going to talk about that. That's a bug that some other programmer will fix another time, not me. Anyways, so yeah, that's how you create composite objects. So, quick lexicon review. What is a rigid body? Rigid body is an industry-wide term for any sort of interactable objects. It contains information such as mass, drag, and center of gravity. If you want to know what drag is, it's kind of like air friction, right? If something has a very strong drag, such as a feather, then that means they move very slowly through the air. And center of gravity, of course, is the center of which it spins at best. You can turn a group of colliders into a rigid body by simply placing the rigid body in the parentmost object. And in doing so, everything starts acting as if they're one single interactable objects. Child, and parent for that matter. Child and parenting is an industry-wide term for an object whose position, scale, and rotation follows that of another object, the parent. The way we did this in Unity, of course, is by dragging and dropping a game object into another, creating a nested element on that game object. It should be worth noting that this follow-parent calculation process is known as forward kinematics, which is a 3D animation term. So earlier when I talked about forward kinematics, that's what I meant. That's what I'm talking about. So let's change some physics. we can actually create how certain objects interact with the world by using what's called a physics material. And the best way to do that is simply going into our project here and clicking on the Create button right below the project pane. One of these materials is the physics material. Create that, it creates new physics material. I'm going to call this bouncy. Excuse me. And see how this bouncy factor is right now set to 0? I'm going to set that to 0.8.
Back up a second. How did you get there? Where did you create?
Create physics material. The Create button is right under the Projects tab.
There it is. Great.
That Create button is there to create literally a new file inside your assets folder. I'm going to delete this because we don't need that. And then you can click on Bouncy. Once you rename that material to whatever you wanted to name it, I'm going to call it Bouncy because I want this material to be really bouncy. You can click on Bouncy. It'll open up the inspector. It'll change the inspector properties. And you can change the bounciness factor from 0 to, say, 1 or 0.8 for my case. You can also change friction too if that's more your jam. And then we're going to click on the sphere. And under the sphere, there's a sphere collider. We're going to drag and drop the bouncy under the material field here. So this to here. This to here. So we can play the game, see what happens. Make sure that you try to slam the circle end because the sphere is what we changed into the ground. And see what happens. Alright, this is a bad demonstration. I am not having... Okay. So in theory, the sphere will bounce a lot more than the square end. Oh yeah, you can kind of see it there. That was a good bounce, if I say so myself. So that's your way of making things more bouncy or making things more slippery. Slippery being by reducing the fraction. I can see a lot of people having fun with this. I'm glad that you're having fun, but the show must go on. Physics material, let's talk about physics material. Physics material is an industry-wide term for how the objects are supposed to interact with colliders. You drop these sort of information on the collider itself. You can adjust on how slippery they are or how bouncy they can be. These materials are physics materials shared between game objects. Changing a physics material's property will update all the game objects with the same physics material because what they're all relying on is the same file. If that file changes, all the other game objects will change as well. Finally, adding sound. Alright, so I created this hit sound. We're going to add this hit sound into the audio source. So the first thing we need to do is go to the cube, and then on the cube we go to add component, and we're going to search for audio, which is right here, and audio source, which is right here. And we're going to drag and drop this hit into the audio clip. So what we did there is we're now saying that the cube is a source of where the audio can be played, and we're adding that audio file, which is called hit, onto that cube itself. If you play the game, you'll hear the sound. And you'll hear it exactly once. Notice how I'm throwing the thing over all around and absolutely nothing is happening. Because to play audio sources, you need to do a little bit of scripting. So we're going to do a little bit of scripting here. Whenever you created the audio source on the cube, right here, we're going to say add components again. At the bottom, it says new script. So we're going to click on new script and give that script a name. Let's say What is the name I gave it? Play sound on collision. Play sound on collision. And that will create a fancy dandy new script right here in the project settings. And you can double click on this to open it. And then in my case, it'll try to open Visual Studios. On a Mac, it'll try to open MonoDevelop. I envy you guys. But the important part is it's going to try to open an IDE for you, and eventually it'll open the file. It's going to take a really long while on my computer, so I'm just going to go right ahead and just tell you right off the bat that this is the code you actually want to copy over and paste onto your script. I will go over what the heck this means, but in the meantime, if it did open, I'll type this in. Incidentally, if you have the slides now, this is the reason why I said you should download the slides. You can copy and paste this information. I wonder if it's up yet. Nope, it's still thinking. Visual Studios, thank you. Yeah, there we go. Highlight, right click, copy selection. Oh, it's open. Cool. So, that's, you can ignore my bracket tendencies and Windows being weird. Here we go. This is what the code is supposed to look like. We don't need this, you can tell, well. But yeah, this is ultimately what it's supposed to look like. After that, you should be able to play the game. And every time the ball slash cube slash whatever you want to call it hits something, it should actually start playing the sound effect. I'm going to leave this up for a little longer. All good? I take the lack of answer as a yes. So yeah, like I said, when you play the game, you should now hear the sound effect. So yeah, basically whenever the object lands, you can hear it play the actual sound effect, which is what matters. So it should be worth noting, by the way, that there's a checkbox called Play on Awake. We probably want to have that unchecked because Play on Awake means when it starts the game, it plays that sound effect. And obviously there's no reason to do that, so make sure you have that unchecked. Other than that, let's actually describe what the heck this code actually does. So, if nobody, I assume a lot of you don't know a lick of scripting. The important part is that this is called a member variable declaration, this is called a function declaration, and this is also called a function declaration. Important part is this part where all you're declaring a variable called audio cache that is a type of audio source. Audio source obviously being this audio source component right here. So we have this audio cache. When we start the game, it checks to see whether this script has a component named audio source attached to it. So this script right here is going to search through all these components on the inspector and find audio source. It takes that audio source and sets it to the variable audio cache at the start of the game, the first frame the game begins. When you declare this function, by the way, the void start, whatever happens within the parameters of these two brackets is what gets called. Likewise, on collision enter is when the cube itself collides into something. When it collides into something, then it'll have the audio. It'll use the audio cache, the audio source information. It'll stop the previous sound effect that it was playing earlier, and then restart by doing the .play command again. So every time it collides into something, it stops the previous sound effect, and then plays the new current sound effect that is attached. So
So if you don't do the stop, does it just build up all the sounds?
no, when you don't do this, when you do the stop, it'll just keep playing the previous sound effect.
Oh, like over
No, it'll just do it first time. So even if it hits the wall consecutively, it'll just play one sound effect. So fun stuff. Oh, also apparently change the spatial blend to 3D. That's a good idea. I should do that too. Spatial blend, 3D. So you might be asking what the heck I did there. Spatial blend stands for how much the distance should affect the volume of the sound effect. If you set it to 3D, the farther away it is, the quieter the sound effect becomes. So it should sound quieter as you walk farther and farther away from that bouncing cube thing big.
Does the geometry in the landscape change the sound at all?
No.
Like the wall in front of it? No?
Sadly, not yet. So we already went through this. Talking about sound. Unity can natively import WAV files, AIF files, MP3 files, and OGG files. Generally speaking, WAV and AIFs are best for short sound effects because they provide you the best quality, but they're also incredibly large. MP3s and OGGs, on the other hand, are a lot better for music files because they're compressed files, but they're also what's called a lossy file, which means that they can lose some information as a process of compressing. So while they're, again, best for music and whatnot, generally speaking, you don't want to use it for sound effect because your sound effect will lose a lot of detail as a consequence of compressing. Music, however, there's not much of a choice because you want to keep the file size as small as possible. Duplicating the cube. All right, this should be fun. Earlier, I mentioned about how prefabs lets you take a group of things and then copy it over to a different scene. So we're going to actually do a process of actually creating that stuff ourselves. When you drag and drop this cube from the hierarchy into the project, it'll create a new file called the cube. And guess what you can do with the cube? You can drag and drop it into the scene all over the place. This is going to be the most recommended method for duplicating anything. You can, right-click on it and say duplicate it as well, but there's actually added benefits on creating a prefab instead of creating a duplicate. Let's get extra creative here and place one cube on top of each other. And get extra creative by placing more cubes on top of each other. More! More! Alright, cool. So I'm pretty happy with this. Yeah! Look at that majesty. So that's how you basically duplicate things. Granted, the longer way, but like I said, with significant added benefits. Is everyone up to this point?
Compiler error.
Let me check. Yeah, open the sounds. Yes, the reason why is because you made the file as text. That would be the easiest one, yes. So that's that. Switch back to the click on the hit. Put the text. Okay, you can press enter. Click on the hit and then press enter. I'll change the place on the don't make it all caps, by the way. Do not make it all caps, by the way. Do make it in exactly the same caps as you have on all the stuff. Now go to your cube and make sure that it's actually attached. So earlier, click on that tip. Move that sound test. Please associate with the logo, please specify compilation variable, that delete sound test. Yep, delete. So go back to the cube right here. And make sure you enable. So now try done again. Really? So yeah, you should be able to pick up those cubes and you should start playing some sound effects. You can click on them. Mouse down, so when you tap on the touchpad, you should be able to tap on them. Does your touchpad not have like a down state? Yeah.
That's alright.
Try control. Go to the FPS controller. Still no, you do it that way.
That's alright.
Alright, sweet. So with the cube duplicated, let's make our level a lot more nicer looking. What we're going to do is we're going to start creating normal maps. The best way to do this is by duplicating our said objects, the grass and the rock. Just click on the grass and you can right click on it and say Oh, it doesn't have that option. Oh, I didn't know. All right, well, you can just right click on that and say Control D or Command D on the Mac. That'll just duplicate that file. I think I'm just going to leave the name as it is. So right now it says grass1. And thanks, Flux, for kicking in. I don't want you here. I'm going to disable you for a good hour. See, my screen is back to normal. But yeah, grass1. Right here under the, when you click on grass1, the inspector will give you what the import settings says. But in this case, it's trying to import it as a texture. We're trying to now, what we actually want to do is we want to import it as a normal map. So let's switch that to a normal map. Create from grayscale, yes, leave it that as it is. The bumpiness, I'm going to change that to a low value for now. And then I'm going to hit apply. When you do that, on the preview at the bottom, your image is going to look very, very strange. Don't worry about it. This is exactly what we're expecting. So once we get to that point, we click on the level. We expand the grass dark, and I'm going to zoom in into the grass, by the way, just to kind of give you a good, nice appreciation of what we're actually doing here. And we're going to change the normal map field here by dragging and dropping grass 1 and into the normal map. And there you go. Notice how the grass looks a little more bumpier, more beautiful, right? A couple of other things you can do is we can probably decrease the smoothness factor to something a lot smaller so that, you know, right now our grass looks super duper shiny, but let's decrease that to like right around here. So now our grass looks a lot more like a grass. You can do the same thing with the rock. The rock, you just duplicate it using the same shortcut, the Control D or Command D shortcut. Change that import setting to normal map. We're going to go with a slightly higher value, this bumpiness value this time, and hit apply. We're going to zoom in on the rock right here because that sounds like a fantastic idea. Click on the level, expand the Horton rock wall, and we're going to drag and drop that rock 1 texture onto the normal map field of that model. You can already see it being more bumpy. And actually, I'm going to increase this. I'm going to slightly decrease the smoothness factor, but increase the metallic factor. The metallic factor actually starts reflecting what the skybox color looks like. And actually, I'm going to switch back to rock_1 here and make it just a tinge bit more bumpier. Yeah, that looks good. So already, like, the graphics look a lot nicer than before. You can also change the color too. I totally forgot about that. So when you click on the level, there's a bunch of colors right here, such as the albedo. Feel free to change that if you feel like it. I guess we can kind of make that rock really, really nasty looking. But far more importantly, you can also do the same thing for the directional light as well. Actually, scratch that. Looks like I have some lexicon things to talk about. So how are you guys doing right there? Having fun? Looking nice? Looking like a VR application?
What is the ANSI level?
Huh?
It's called like an ANSI level.
Oh, the ANSI level.
Yeah.
I set it to 1.
Or does that change?
Hmm?
Or does that change? It's okay.
I don't remember. Oh no, ANSI level changes the number of different layered details that it creates. It's a very technical term. Anyways, so I'm going to quickly talk about normal maps. What does a normal map mean? Normal map is an industry-wide term for images that represents the direction the light is supposed to reflect off of a model's surface. That's why when you saw your image file, it looked like this weird purple shade. That's just how that data is being represented. The model's UV coordinates indicates how a normal map is mapped to the model itself. And yeah, that's basically just it. The materials, what we've been changing all this time, changing the color of the material and so forth, is the material object. The material is an industry-wide term for what the surface of a model is supposed to look like. For example, you can change it so that it'll look like it's a metal thing. You can change it so that it looks like a plastic thing. For plastic, you just have to make it not look metallic, non-shiny stuff, so on and so forth. You can see that we can already create a lot of different variety of visuals by just changing, the smoothness factor, the shininess factor, the metallic factor, and so forth. Because materials are files, that means that if two game objects are sharing the same file, both of them will be updated. So that's what this bullet point, changing a materials property will update all the game objects mean. Models retain the information on how the materials are mapped to the surface. So in our case, we have a single modeled level which has a couple of different surfaces, the grass surface and the rock surface. And both of them are using two different materials. Unity will attempt to create a materials based off of the information that model contains. That is why when you started the project, it automatically created two materials, the grass dart and the Horton rock wall. And if you check the materials folder, you can find both of those files in there. I just didn't talk about it because I wanted to get through the tutorial real quick. But just to let you know, Unity does actually try to make stuff for you whenever it's importing models. Last thing, directional light. Directional lights are fairly simple. When you look for it, there's a directional light under a hierarchy. I'm going to drag that more towards the camera here, only just to make it simpler for myself. Just to let you know, the position of the directional light does absolutely nothing, so don't worry if nothing seems to have changed. Then you can use the rotate control to kind of change the direction in which the light is facing. That didn't do anything. Let's space it over. Oh yeah, that looks like a good color right there. Yeah. And you can also change the color under the inspector of that light. So right now it's kind of like golden yellow. We can change this to depressing blue. Or under the water blue. Or the 7 green. Or for some reason purple. Let's go with for some reason purple. And then you can increase the intensity of this light. That'll make, basically the light stronger. And in doing so, you can play the game and observe your completely alien world that you created for yourself. Oh yeah. So awesome. Note that if for whatever reason you don't see any light changes, there's a little toggle right here that indicates any light changes. If you check that, if you keep that pressed, you'll actually see the light being affected. If you don't, this is what it looks like in the most boring non-light world. But we have lights, and that's what is important. About lighting, lighting can easily be created by going through the game object menu with this new light thing here. And there are a couple of different of lights. Sorry I don't cover them on how you use them in this tutorial, but here there are. The direction light is basically sunlight. It's all light moving in the parallel direction. The point light is any light emitting from a single point, and a spotlight is basically a flashlight-like thing, where it creates a cone of light. And finally, the moment of truth. We're going to build an executable. And this is the part where people who were just installing Android Studio, now is a good time to go through and make sure that under Edit, Preferences, that you have filled in the SDK and the JDK file in there. If you have not, please let me know and I'll try to help you out. Excuse me for all that. Sorry. Oh yeah, preferences. Alright, so those are external tools. And right now you have JDK and MDK. Yeah, no, that's not supposed to be where it is. You had installed an Android Studio. That's it. Where is it? Do you have to open? Oh, but you're making for sense of VR. But in this process is not necessary for you. Anyone using Android Cardboard that hasn't went through this process yet? I'm looking at you, Robert.
I'm stuck here.
So in other words, you need to install JDK. Alright. Yep. I'll actually go over that. Give me a minute. All right, so I'm going to assume that everyone has went through this process. I'm going to talk about the build setting process here. If you're doing, actually this is applicable for Android and iOS as well. Go to player settings, and right here it'll say bundle identifier, com, company, product name. Unfortunately for us, we actually do need to change this bundle identifier. So I'm going to call this bundle identifier tvgs and product name VR. So com.tvgs.vr, just for the sake of letting Unity know that the bundle identifier is a different name entirely. Thank you, Patrick, for pointing that out. And then from there, you can either hit build or build and run. If you don't have your device connected, I would recommend just hitting build instead. Oh, whoops, excuse me, I forgot about it. The first thing you need to do, is add open scenes. We already have a scene open. By the way, I would recommend saving this scene. So we just have to click on add open scene once. You might notice that added in a VR level scene inside our scenes in the build list. So that's good, it's checked, that's awesome, that's exactly what we need. And then from there, we just hit the build button. And you just need to build it to a specific folder. I would recommend pulling it in a folder that is not your project. So I'm gonna pull it on the desktop here and say, awesome APK, because I have creative names, and it should build. Now, just to let you know, from past experience, my computer does not build, but don't worry about it. I'm not worried about it. Just making sure that everybody else actually builds first. Actually, you know what, Samsung I actually never bothered to figure out why this was happening. Might as well Google it too. Huh? 1.8 also works as well. That is not what I want. Did you get it working? Woohoo! So apologies for taking a long time. I'm going to quickly skip over a couple of things. I know a lot of you are just waiting for stuff to be installed. Sorry, I don't have that. I apologize for not having enough time to talk about the installation process, the Android-related stuff. But what you do have some time for is some sort of reference material. At this point, the tutorial is pretty much done. Oh, I should have mentioned about Save Project. I forgot about that. Make sure that when you're saving file, there's also a command called Save Project. I would highly recommend saving that as well. Save Project handles the import settings of how you import all your assets in your project. That is close to done. Some supplementary materials. I would highly recommend checking out unity3d.com/learn/tutorials. Unity itself has a wonderful selection of tutorials to check out. So if you want to learn more about other components in Unity, such as how to do mesh navigation so that you can kind of point at a direction and make a character move to that point, there's a tutorial for that and so forth. If you want to learn more about scripting, each component actually has this question mark book icon to it. If you click on that, that actually leads you directly to the documentation of how to work with that component. So if you have any questions about how certain things work, this is the icon that you can click on to learn more information about that. One last thing that's really cool and awesome is that you can open the asset store, which is under the Windows folder. And when you do that, it will give you a collection of all the assets you can download and import to your project. Of that, the one thing I obviously recommend is the Unity VR sample created by Unity themselves, where it creates a whole slew of scenes and applications that you can run on your own VR device and compile them. So again, just search for Unity VR sample. It's a completely free project. Feel free to create a new when you're downloading it. I would actually recommend creating a new project entirely first before downloading it. But yeah, just hit download, you hit import, and it will create all these selections of really neat VR demo scenes for you. And you can kind of look through its source code, look through its material, and learn from them. And that's actually it. That's all I had to bring about that. This last slide, if you're interested, is for programmers. I assume the grand majority of you are not programmers, so I'm not going to care about that. Any other questions? Outside of help me build the application? Yeah.
For the script for the sound and collision, is there a way to do it so when certain objects collide with other objects, it makes different sounds?
Yes. There are a couple of ways of doing this. So I don't know if how much knowledge of programming do you happen to have?
I have
Java experience? No, that's good. That's much better than I initially expected. So you know what if statements are, right? If true, then that. All right, so the one parameter is the collision right here, the collision information. From the info, there is something called info.collider, which is the information of what the other collider is. So you can grab some information from those other colliders. One easy example is, let's say for example, we want this level to have a different sound effect than each of these. So I'm going to choose a level in this case because it's just faster and easier. One easy method is to create a new tag. Right now it says untag under the tag formula right here, but I can, for example, change this to, these are all terrible, I'm just going to say add tag level. So we can set that to level, and then when I go to the script, I can say if collider is compare tag is level. Level equals true, that's just my habit in programming. Then I can make it so that a completely different audio source is being played instead of the initial audio cache right here. One thing I didn't mention is that if you set the audio cache to public, then one thing you'll notice on the cube here is that right here at the script, after it thinks for a little bit, come on, there we go. So now, notice that now it created a variable called audio cache that you can actually fill in anything with. You can basically drop the cube's audio cache there. I mentioned earlier that prefabs gives you some extra fancy things. You can just click on the cube right here, and then, so I just created an audio cache here, and I can drag and drop there. If you do that, all these prefabs becomes updated with a proper audio cache. You can tell from the field right here that when I switch between different audio caches, that the audio source changes to the proper one. So anyways, that is your way of saying, all right, I want you to play this specific audio source on that object. You just have to now create a new variable, audio cache level, I'm going to call it. Also, I'm just going to completely take this out for now. And have it so that instead of playing the original audio cache, you can have it so that it's playing the audio cache level instead. Now that you're going to have to create a new audio source. I would recommend creating a new game object directly under the cube. I think the best way to do that is, okay, I guess it doesn't let you do that, never mind. The best way to do that is take the original cube right here. I'm just going to create a new audio source. That created a new audio source right here. We only have one sound effect, unfortunately, so I'm going to use hit, but I'm going to, and spatial blend of that, but I'm going to make its pitch super low. So that's fine. And then the cube, right here, the audio cache level, we're going to set that to the new audio source that we've just created. And you can hit the apply button. The apply, you just noticed that the cube icon right here changed. Apply basically applies the changes to the file itself so that every other cube now has all these variables set. Whereas previously, if it was not a prefab, you would have to actually set all of those individually, which is why in the tutorial version, I make you go through the process of actually creating a prefab. Anyways, so prefabs allows you to update multiple objects at once. All right, that was a very poor example. Yeah, that was a really poor example. Let's look for land. Oh, whoops, I forgot to. Come back. It may also just be that I misspelled level, which would not surprise me. No, I did spell that correctly. And I did say audio cache level, check to see if the compare tag is set to level. Okay, so this should in theory work. It doesn't even play a sound effect, which is really weird. I don't know why it doesn't. All right, so in theory, that's supposed to work, but that's the line of logic to that. You do it through script. Any other questions? Well, without further ado, that's the conclusion of my lesson. Sorry to see that only one person was able to successfully build their application there, but I can spend just a tiny bit more time to make sure that a couple of Android people here also have their application working and buildable on their Android devices. But unless there's no further questions, like I said, this concludes my lesson. So
Thanks, man.
yeah, no problem. And I'm gonna leave it to Jamie.